Physics lecture number 8, adding perpendicular vectors. And previously we added vectors by drawing pictures. This time we'll draw a sketch of vectors being added together and use trigonometry to find the size and direction of the resultant. So here's a problem. A car moves 3 meters east, then 4 meters north. Find the direction and displacement from the starting point. So here's how we're going to solve it. First we're going to sketch a picture of the two vectors. We'll draw the first vector and put a big dot at its tail. So the first vector is 3 meters pointing east. So these aren't going to be to scale, this is just going to be a sketch of what we're doing. So let's see, I guess we can do it right here. So there's our first vector pointing to the east, that's in this direction. And we're going to put a big dot at the tail of the first vector. All right. So here's our first vector, 3 meters, pointing to the east. All right. And we put a big dot at the tail of the first vector. And then we're going to add dotted lines at the tail of the first vector to indicate that's the origin of the graph. So right here, I'm just going to put little hatch marks like that. Okay, so the tail of the first vector, that's always going to be sort of the origin. All right, we're going to draw the second vector and we're going to place its tail at the head of the first vector. So the second vector is 4 meters north, so we have an arrow pointing up. So I'm going to draw an arrow pointing up, and then the tail of that vector is going to be at the head of the first. So our second vector is pointing up like that. So here's our second vector. The tail of the second vector is placed at the head of the first vector. All right, now finally I'm going to draw a line from the tail of the first vector to the head of the second vector. So the big dot, that's the tail of the first vector, and we draw a line from the tail of the first to the head of the second. Like that. Okay. And notice that we've drawn a right triangle. The resultant here is the hypotenuse of the triangle. And we can use the Pythagorean theorem to solve for r. So, if we use the Pythagorean theorem, we would do it like this. R squared, the hypotenuse, is going to be equal to 3 squared plus 4 squared. R squared is going to be equal to 9 plus 16. R squared equals 25. And then R is going to be equal to 5 meters. So that's the displacement. That's half the answer. To find the direction, we need to find the angle at which it's walking, or the direction. So when you try to find the direction, you're basically trying to find the angle, and the angle that you're trying to find is always located near the tail of the first. That's why you put a big dot at the tail of the first to tell you where the angle is that you're looking for. So we're trying to find this angle. It's always near the big dot. All right, now we can use the tangent function to find the direction, this angle, of the resultant. Now you might recall that tangent of an angle is going to be equal to the opposite side over the adjacent side. In this example, the tangent is going to be of this angle. It's going to be the opposite side, so the side opposite this angle is 4, over the side adjacent to the angle, 3. Alright, so this gives us tangent of theta is going to be equal to 1.333. And then to find this angle, we do the angle is going to be equal to the inverse tangent of 1.333. 3, 3. And the way you find the inverse tangent, it's different on different calculators. On this one, you would do something like 1.333 second function tangent, and that gives us 53.1. So this angle is going to be about 53 degrees. We have to give compass directions. This direction is east, and this direction is north. So this is 53 degrees to the north of east. So our answer is 53 degrees north of east. So those are the answers. That's the direction, and that's the magnitude. Let's try one more problem like this just for practice. A bird flies south at 15 kilometers per hour with respect to the air. The wind blows 40 kilometers per hour due west with respect to the air. Find the velocity of the bird, magnitude and direction. All right, well, same steps. Let's draw the first vector, south at 15. So we're going to draw a downward vector. So you draw the first vector, put a big dot at the tail of the first vector. All right, so here's our first vector. Second vector is going to be an arrow pointing to the west. All right, and we put the tail of our arrow at the head of the first. So here is our second vector. And this one is 40. And I'll put in my little graph marks there. All right. And then you draw a line from the tail of the first to the head of the second. Like that. All right. So this is our resultant. And then what angle are we trying to find? Well, here's where the big dot is, so this is the angle we're going to try to locate. All right, so to find the magnitude, we use the Pythagorean theorem. I guess I can do it over here. No, I'll do it over here. R squared is going to be equal to 15 squared plus 40 squared. R squared is going to be equal to 225. Plus 1600. R squared equals 1825. Take the square root of r. That's going to give us about 42.7 or about 43 kilometers per hour. All right, so that's the magnitude. We just found that right here. To find the angle right here, well, let's see. We'll do tangent again. Tangent is opposite over adjacent. Tangent of theta is going to be 40. So the side that's 40 is opposite the angle, and then 15 is adjacent to the angle. Tangent theta equals 2.66. All right, and then the angle is going to be equal to the inverse tangent of 2.66. And then on this particular calculator, you would do 2.666, 2.666, second function tangent. I get 69.43. So the angle is 69.43, which is about 69 degrees. Then we need compass directions. Well, down is south, and this direction is to the west. So this is 69 degrees to the west of south, west of south. All right, so there's our direction, 69 degrees west of south. and the magnitude is 43 kilometers per hour. Now, in some cases, we're given a diagonal vector and we want to know the vertical and horizontal components of the vector. In this case, we use sine and cosine to find the vertical and horizontal components. A cow wanders 80 meters, 25 degrees north of west. How far north has it traveled and how far west has it traveled? All right, what we're going to do is we're going to draw an x and y axis and add compass points. So this is just to sort of get us set up. So I'm just going to go like that. I guess I can make it like, yeah, that's fine. And then like that. So these are here's my y-axis and here's my x-axis, and we're going to add compass points. This is north, this is south, this is east, and this is west. Draw the diagonal vector from the origin of the graph. So this is our vector. It's going to be 80 meters in magnitude, 25 degrees to the north of west. Well, here's west. Above west is to the north of west. So it doesn't have to be exact. We're just going to approximate it. So we're just going to draw a line like that. Okay. And let's see. So this is going to be 25 degrees right here. And then this is going to be 80 meters. All right. And now we're going to add a line to create a right triangle so the diagonal vector is the hypotenuse. So this line right here is the hypotenuse of a right triangle that we are going to create. I think the easiest way to create a right triangle is just to inscribe a line straight down. We could make a right triangle by drawing a line like this. That would give us a right triangle here, but it's going to be easier to solve if we just inscribe our right triangle like this. So I'm just going to drop this line down like that. So now we have a right triangle where the hypotenuse, where this is going to be the hypotenuse. All right. And so I'm going to label this side, side y, and then this side of our right triangle, I'm going to label it side x. Now, side y of the right triangle tells us how far north the cow has traveled. And we can use the sine function to solve for y. Side x of the triangle tells us how far west the cow has traveled. And we can use the cosine function to solve for x. So I'm going to solve for y first. I'm going to use the sine function. Sine of 25 degrees is going to be equal to the opposite over the hypotenuse. All right. Sine 25 is going to be equal to the opposite side, y, over the hypotenuse, which is 80. All right. And then sine 25, well, on my calculator, 25, and hit the sine button, it's going to be 0.4226. So 0.4226 equals y over 80. And then if you solve for y, you would multiply both sides by 80, so you'd end up with y equals 0.4226 times 80. That's how you solve for y. Multiply both sides by 80. That cancels. So y equals 80 times 0.4226, which is what we have here. And then, if you solve for y, you'll end up with something pretty close to 34 meters. It's 33.8, which is about 34 meters north. All right, so that's the answer to the first half. How far north has it traveled? About 34 meters north. Let's figure out how far west it's traveled. For that, we'll use cosine. Cosine of 25 is going to be equal to the adjacent side over the hypotenuse. So it's going to be cosine 25 equals, so here's the angle, and then x is the side right next to or adjacent to the angle. So it's going to be x over 80. All right. Cosine of 25. On my calculator, 25, hit the cosine button. 0.9063, 0.9063 equals x over 80. I want to solve for x, so I'll multiply both sides by 80. So if you do that, and it's kind of hard to do here, 80 and then times 80, that will cancel. So x is going to be equal to 0.9063 times 80. X is going to be 72.5. That's pretty close to 73 meters west. So that's the second part of the answer. How far west has it traveled? About 73 meters west. In terms of rounding, in high school they say if it's 0.5 or above, you round up, so that's what I've done here. In college, if this is an even number, you would round down. So in college, I guess you would round down, but in high school, we'll round up. Okay? For a PDF transcript of this lecture, go to www.richardlurie.com. This has been physics lecture number 8, adding perpendicular vectors.